All right, today we are going to be talking about exponential growth and decay. Exponential growth and exponential decay, excuse me. So we're on page 165, and we're going to start off with a little bit of vocabulary. So exponential growth is a function that increases faster and faster. So it's shown by a graph that starts increasing, goes faster and faster. So there's exponential growth. It increases faster and faster. And a function of exponential growth would be what we worked on yesterday. So it's just a function that increases faster and faster. And that could be represented by the function ABX. And for growth, B is greater than 1. So B is going to be greater than 1 for exponential growth. Now, exponential decay is where something decreases faster and faster. So it's decreasing faster and faster and faster. Exponential decay. And an exponential decay function it's the same function, except that B is in between 0 and 1. So B is greater than 0 but less than 1. So B might be, it might be 0.25, might be 0.1, might be 0.9. It's anything between 0 and 1, but you notice it's not a negative number, so it's in between 0 and 1. Okay. Compound interest, we're going to not deal with that for today. We'll deal with that later. So, if we look here on the bottom of the page, it shows what exponential growth looks like. And this growth factor right here, this is B. That is our B value. So, we're going to look at a couple today where it says that the rate of change might be, say, 11%. So we're going to turn 11% into a decimal, and that's 1. So growth is 1 plus our rate of change. So growth is plus. Whereas decay is 1 minus the rate of change. 1 minus the rate of change. So the nice thing is you can flip back and forth and you can see growth and decay. You can see the two formulas for growth and decay. Again, compound interest we're not going to work with today. We're going to leave that until we get an understanding of exponential growth and exponential decay. Alright, let's start off. I will do the odds, you do the evens, and then today you will have some extra practice in you'll have a worksheet to do because this is so small, and I don't think it helps you practice well. So we practice a little bit. Number 1, in 2005 there were 100 rabbits in Polygon Park. The population increased by 11% each year. So if we look at our formula, which I'd like you to write down, f of x equals a 1 plus r times t. And A is A equals initial amount. R is rate of change. And T is time. So make sure you have that from exponential decay and exponential growth. There's your formulas, and I just wrote it. I just rewrote it right there at the top of the page. A times 1 plus r times t, or to the t power. So write an exponential growth function that represents population t after 2005. So here, 100 is our start. So our function is our starting value, 100, times 1 plus 11%. Now, you have to know how to change percents into decimals. So 11%, to a decimal you have to divide by 100. And so the decimal is 0.11. And to go from decimals to percents, you go that direction. 0.11 times 100 equals 11%. So what's 11% in a decimal form? 0.11, because we have to work with decimals, we're not working with percents, to the t. So if we simplify this, we have 100 and then 1.11 to the t power. Now let's put that into practice. What will the population be in 2025? Round your answer to the nearest whole number. Well, now I have 100 times 1.11 and 25. So I started in 2005, I went to 2025, so 2025 minus 2005. So my time is 20 years. So I'm going to put this equation into my scientific calculator here. 100 times 1.11 to the 20th power. And I get 806.23. Round to the nearest whole number. 806.23, blah, 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 round to the nearest whole number. So I have a population of 806 rabbits. Yikes. Too many rabbits. Okay. Next, section 2 through 5. Determine whether the table represents exponential growth or exponential decay or neither. So all we have to do is decide if it's an exponential, and then if it's going up, it's growth, and if it's going down, it's decay. So here, our numbers are going down. So if this is exponential, it'll be decay. So what I'm going to do is I'm going to look at, let's see, how do I get from 160 to 40? So 160 divided by 40 is 4. So if I multiply this by 1/4, I get 40. Let's check 40 times 1/4. 1/4 is 0.25. Oh look, there it is. Times 1/4, just 0.25. And let's check the last one. Times 0.25. Oops. Oh, that's correct. Times 1/4. So I do have an exponential, and it's decay. Exponential decay. And this one I accidentally started doing in the book. I have a growth 2.5 multiplied by 2.5. Again, 10 times 2.5 is 25. 25 times 2.5 is 62.5. So this is exponential growth. Now, keep in mind I have to multiply. For it to be exponential, it has to be a change rate multiplied. It cannot be addition or subtraction. So if you do get addition, ding, 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 or subtraction, I'm sorry, then that would be linear and not exponential. All right. Determine whether each function represents exponential growth, which is b is greater than 1, or decay, which is b is in between 0 and 1. So the easy way to figure that out is if I have less than 1, it's decay, and if I have greater than 1, it's growth. So you got that one. This one is growth. And you got that one. Okay, word problems, but it's okay because we have our trusty formula. So let's check this out. f of x equals a times 1 plus r to the time. So we are not going to do compound interest. So we're just increasing this yearly. So we're not dealing with the compound formula. We're dealing with this formula. So we're going to plug the pieces into here. So for this one, our original deposit is $3,000. And it's times 1, let me see, 6%. 6% divided by 100, I get 0.06 plus 0.06 t. There's my formula for number 9. So go ahead and do number 10. All right. Check out on the module. You'll have a worksheet. You have some problems to do on the worksheet. If you have any questions, please call me or email me, or you can Zoom. Let me know if you have any questions. Okay. Have a great day.